Hello everyone, myself Sarah from group number 322 and my topic is structural instability. So let's start with the definition. What is structural instability? Structural instability is a phenomena where a structure deforms a lot while the external force increases by a small amount. It means that when we apply small amount of external force will apply it in a small amount, there will be a change in the structure, there will be deforms in the structure. And when we'll apply small amount and the we will see the structure deform will be a lot. Okay, so structural instability is a phenomena where a structure deforms a lot while the external force increases by a small amount. So, the elastic stress analysis of structures is based on the assumption that the applied forces produce small deflections. So, what is this elastic stress analysis is based on? It is based on the assumptions that the applied force produce small deflections. Okay, what we said here, only small force produce a lot of deform. So the same is here, applied force produces small deflection that do not change the original geometry sufficiently for effects associated with the change of geometry to be important. Okay, so it may change the shape, but the actual material it won't change. In many practical structures, these assumptions are valid only up to a critical value of external loading. Means there is exception for this. It is applicable only for a limited things, only are valid up to a critical value of external loading. So buckling. What is buckling instability? Buckling instability is a treacherous phenomena in structural engineering. So it takes a very great importance in structural engineering, where a small increase in the sudden loss, very small increase in the load small increase in the load can lead to sudden contractive failure. Means it should be accurate. If it will be a small more than the load, it can lead to a sudden change, a sudden failure. It is sudden loss of stiffness at a critical load. It is a sudden loss of stiffness. There will be loss of stiffness at the time and sudden failure for the substance at a critical load, which results in deflection to a side. It may result in the deflection to a side where instability occurs. Wherever Whenever a light or thin component is subjected to compressive load, so when a light or a thin component is subjected to a compressive load, the possibility of buckling should be considered. So when buckling will take place, when there will be a change, component change, possibility of buckling is considered. It should be noted that a pure shear tensile and a compressive component, and so the structure might buckle under this condition. So we should keep in our mind that when the buckling will occur, when there will be small change, whether it is in the force or in this, so buckling will take place. Okay, structure might buckle under these conditions. Okay, it should be noted that a pure shear load on a plate or shell can be resolved in a tensile or compressive component. So in context of biomechanics, buckling is most likely to occur. So in the case of biomechanics, buckling is most likely to occur where buckling occurs in long slender columns like long bones, in thin shells, the orbital floor. Okay, so these are the conditions where they should occur and not occur. Euler theory. What is Euler theory? Work on buckling of columns was developed by Euler in mid 18th century. So what is a work on buckling columns were developed by Euler in 18th century. Euler methods are attractive for the solution of simple columns with a simple restraint conditions because of the solution are closed, form and accurate. So we should take in our mind that it is short, accurate, and where this Euler theory should work. And the buckling theory is most important because a small changes may lead to a drastic change and may cause failure for the instability and structural instability. Thank you.